Here's our application problem on the lesson 8.3 notes. It gives us the height and feet of a basketball that is thrown is modeled by this equation right here, where x represents time and f of x equals is going to represent height. All right, so the x values are time, and whatever you plug in and for your x value, your y value is going to represent the height of the basketball. Find the basketball's max height and the time it takes the basketball to reach this height, and then find out how long the basketball is in the air. So we need to tackle three things here: the height of the basketball, the time it takes to reach the height of the for the max height of the basketball, and the time it takes to reach the ground. So if you think about when something is thrown in the air, it always is going to follow a trajectory that looks like this. It's going to be an upside down parabola, right? It's going to be thrown in the air, it's going to peak right in the middle, and then it's going to come back down to earth. So what we want is this middle point here. That'll give us the max height, and it will also tell us the x value where it reaches that max height. Or in other words, what we really need to find is the vertex. That's what we really want to find, x comma y, for the vertex. So we could do that by doing our vertex and we know how to find a vertex by now. It's negative b over 2a. That's the x value of the vertex, which in this problem it's going to be the negative of 32 over 2 times negative 16. Remember, this is a, this is b, and the number over here is c. There is no number over here for c. C is 0 in this case. So the x value of the vertex is going to be negative 32 over negative 32, which is really just 1. That's our x coordinate of the vertex. To find the y coordinate, we would plug that in. So y equals negative 16 times 1 squared plus 32 times 1. Ran out of space like I always do. That's going to equal 16. So what this represents, 1 comma 16, is the maximum height of the basketball. All right, it goes 16 feet in the air, and it takes 1 second to reach that. So max height is 16 feet. It takes 1 second to reach max height. Then the only other thing we need to find is when does it hit the ground. So we could graph this over here, 1 comma 16. So this scale is going to go by 2's for the y's. So we're going to have, and halves by the x's. If you see the way this is scaled, 1 comma 16 would be right there. That's 1 comma 16. Okay. And then we want to figure out when it hits the ground. So we'll take the function and we're going to want to factor it. Negative 16x squared plus 32x. We could factor that. We could pull out a GCF. Our GCF is negative 16x. What's left over is x minus 2. We set that equal to 0. Okay, so x is going to equal 0, and x is going to equal 2. Those are going to be our zeros of this function. So these are the zeros. So at 0, at 0, and at 2, our function is going to look like this. So we know that's the path of the basketball. The basketball is going to hit the ground at 2 seconds, right here. That's when it hits the ground, right there, 2 seconds. Okay, and that's it for this video.